Hello, this is a video on calculating combined gas law problems. Um, so by this time you should have gone and listened to the video about the steps you must follow for any gas law problem. And the first one, and this is what it is, it says how many conditions. So the first thing you have to do is figure out how many conditions there are. And the second thing you should need to do is if it has two conditions, meaning you're doing something to the gas and you see action verbs, then the next question is how many parameters are being held constant. Now, if you most likely you have watched the gas laws and Avogadro's hypothesis videos, and if not, that's okay. If you did, you realize the fact that all those have holding two things constant and varying two, and they're all two condition problems. And if you look at your overview, you can see that in the section that's two conditions, there's actually another type of gas law that where you don't hold two things constant, you only hold one thing constant, and it's called the combined gas law, and that's what we're going to look at today. So the number of things that are being held constant is 1, and when it is, the only thing that we hold constant is the number of moles. So the balloon isn't leaking. Could you do other ones, other variables? Yes, but for this level, we only do one parameter, and that's number of moles. So therefore, you have 3 additional variables. You're going to vary 2 of them, and you're going to calculate the third. So, so the next thing is, as you can see in the steps, we got to declare our variables, and we got to figure out our mathematical equations. The combined gas law is exactly what it says. It's a combination of all the gas laws. So, so we can determine, basically it's instead of having one variable in a bracket with a ratio of the variable that is changing, we're going to have 2 brackets since 2 variables are changing. And determine where the subscripts 1 and 2 goes is depending on if it's an indirectly or directly proportional relationship between the 2 substances. So basically, the combined gas law just combines all the gas laws into the mathematical relationship. So we'll take a look at an example. Oops, that's the wrong one. Let's see, here it is. So, so if you read the question, you see that that you are doing something to the balloon or the gas. You can see the word decrease, okay, heat. So you are doing something, and also you know it's not a gas law Avogadro's hypothesis because of all the information they get with gas laws and Avogadro's hypothesis. You need 3 things to solve the 4th. Well, we actually have 5 things. So therefore, that's another indication. So gas law is that you have 5 different pieces of information because you're trying to solve the 6th. So therefore, it's a gas law. I mean, it's a combined gas law. Again, and it's being held constant. So if you look, what you're looking for is you're looking for the new volume. So V2 is equal to, well, just like in the gas law, it's a function of V1. Now, the difference is we don't have one variable changing, we're changing 2. So we change the temperature, and we're going to change the pressure. Now, how do you know where the subsequent 1 and 2 is for temperatures and pressure? Well, volume and temperature are directly proportional. So if V1's on the top, T1 must be on the bottom. The other one is pressure. How is volume and pressure related? Well, it's inversely or indirectly proportional. So if V1's on the top, P1's on the top, and then you know where the 2's are. And a lot of times what I'll do is I'll set it up just like this without the little subscripts, and I'll put the 1's in the right spot, and then I'll just fill in the 2's. So there's your equation. And it works just as well for T2 and P2. Okay? And just to check, how is temperature and pressure related? Well, they're directly. So T1's on the bottom and P1's on the top. So that proves it. So you declare your variables, temperatures have to be in K. You plug in, and then you get your answer. And again, remember that the units, K, T, you have to have in K. But pressure, in these, the pressure just has to be the same units. So that's how you solve a combined gas law problem. And again, to create the P2 equation and the T2 equation, you simply build it like I just built that V2 equation. Okay? Thank you.